right, so welcome to the talk. It's called Unity Tech for Indies, less bugs, more gameplay. Who am I? My name is Marko Grgic. I'm an indie game developer from Brisbane. Name of my company is Super Fun Games. It's just a tiny little company. And I'm making Ravencall, which I'm not really announcing yet, but there you go. I also port games to the Nintendo Switch. And previously, I was at Three Blokes Studios, so I was one of the three blokes that founded it. And then went to do my own thing for a while, and then I was at Defiant Development for a while. I got a cool sword out of it and everything, working on Hand of Fate 2. And that was awesome. That game that was really well received, and won first place for Game of the Year at AGDA last year, which was awesome. So, throughout my game development career, I've worked in multidisciplinary work environments in different game spaces: casual games, social games, mobile games, and again, now back to PC and console games. As a result, I've worn many hats over the years, which has made me appreciate all the different parts that come together and to actually build and ship a game. I've also been fortunate enough to be involved with the business side of making games, which, while really terrifying, helps put a focus on where you should be spending your time and energy. These are some of the games I've worked on over the years. Mechanics range from match 3, hidden object, platforming, arcade, base building, and of course, collectible card game text adventures with RPG action combat. There's the next one. So, there's three main topics I wanted to cover today. Asset bundles, what I call data validation, and I went to a few other talks, other people are calling that too, so that's great, and some workflow helper scripts. There will be time for questions at the end if I'm quick enough. But first, I'll try to... Sorry, I put a bit of a silly joke in here. I'm just going to skip it. Another title for this talk could have been How to Lose Most of Your Tech Battles, but Still Slay the Beast, where slaying the beast means shipping the game, selling copies, and escaping the jaws of the ever-looming threat of bankruptcy. So, the go-to for programmers can usually be over-investing time in tech and systems. To avoid falling into this trap, you must weigh up time spent on tech versus other game-related implementation and try to do your best to maximize your return on investment. Now, I know what you're all thinking. In the Fellowship of the Ring, Gandalf says, "Marko Grgic, do not take me for some conjurer of cheap tricks. I'm not trying to rob you of your precious development time. I'm trying to help you to build scalable and easily maintainable code." So, of course, we must give wizards and programmers their due. The goal is common: to save time over the course of the project. But how, you ask? Good hypothetical question. A difficult question, but a good one. When attempting to answer this question, it's easy to settle on one answer and lead yourself astray. Unless you're well versed in design, art, marketing, etc., all the different parts that come together to make the whole, unless you're able to see the big picture, to predict the end result. And that's impossible. An impossible destination, but a great direction. You'll cry, you'll fail, you'll learn, and over time, you'll get better at it. This nebulous thing, this cross between code, design, art, business, this abomination that causes heartache and swallows projects whole. I don't want to focus too much today on the beast itself. Instead, I want to share my experience, some code, and a sample project that contains some of the tools I used to fight it. So how exactly is this supposed to help? Well, data validation and workflow helpers sit in the crossover between tech and other disciplines, a place which the beast occupies, if you will. And they have a clear purpose. It's not code for code's sake, as fun as that can be for programmers, myself included. Sorry, I got a little lost. That being said, the usage for each game can be unique. Why asset bundles? Well, because I see them often neglected by small teams, and out of the various reasons to use them, I will be focusing on two, because I'm talking about mostly asset bundles for desktop and Nintendo Switch. So for mobile, you'll want to care about size and so on and so forth, but I won't really go into that. The two advantages of doing them for these platforms is you get shorter build times if you've set them up properly, and you also need to do them for Nintendo Switch pretty much, to get to pass the initial sort of lot check process, and then if you want to do updates, it's required. So I certainly don't have all the answers, and I'm well aware of that. Take the bits from this talk that makes sense. Ignore the stuff that you think is stupid. In order to show off the tech, I've thrown it all into a sample project. 3D Game Kit is a free asset on the Unity Asset Store and contains a bunch of data in it. I've also added a tiny bit of RPG project data into it as well. So it's some character classes and some stats. Sorry, I keep getting lost. It does contain some beta features, though, and preview packages, so I don't recommend grabbing it as a starting point for a project. Just have a look at it and pull across the tech that you find to be useful. I've put these slides and the sample project in my Dropbox, and you can see the link already. And it's also in the lower right of every slide if you miss taking a photo. Feel free to use the stuff that I've done for whatever you want, no restrictions. And for the 3D Game Kit stuff, check the licenses in the project. At a glance, there wasn't anything too scary in there. All right, so if you haven't seen it before, this is the 3D Game Kit. It has some bare bones game elements and contains various Unity features. You control Alan, which is a space explorer. It's a third-person camera game. There's platforming elements, there's a tiny bit of combat versus alien creatures, there's a bunch of crates around that you can smash, there's healing chests that heal you, there's pressure pads that open doors, etc. That's the intro done. Let's do a really simple look into asset bundles. If this is the first time you're hearing about asset bundles, you can think of it as putting your assets into a bunch of boxes. I've added Asset Bundle Manager from GitHub, and I've done a modified version that I've used on some projects already to the sample project. It handles the building and loading of bundles. I'll briefly go over some basic usage for configuring assets to be put in bundles and how to initialize the Asset Bundle Manager. I've also pulled down Asset Bundle Browser from GitHub. It's a tool that assists with viewing what bundles will look like and what the dependencies between your different assets looks like. The implementation of Asset Bundle Manager I've used in the sample project is very simple and dumb. It's almost identical to the original version provided by Unity. You can find more versions of it up on GitHub, which support unloading bundles. That's something that's missing from the version I've used. Feel free to customize how the bundle manager works or how it builds bundles and whatever else works for your project workflow or build pipeline. I've got it set up with a desktop console target platform in mind, and so mobile downloadable content setups will definitely differ. I've added a small class that helps initialize the bundle manager, and it has an example code of how to load an asset from the bundle. So what I've done is I've added a loading scene. It just shows, I'll just backtrack a little bit. So because it was a project that already had a whole bunch of stuff in it, I approached adding the Asset Bundle Manager like I did with any other project where someone's not used asset bundles and I'm adding asset bundles into it. So what I usually do is I add a loading scene that just shows a loading image while the bundles and main menu load, initializes the Asset Bundle Manager and loads the next scene, which in this case is called Start. I've removed all the other scenes from the build settings so they don't get included in the build and instead are loaded through their asset bundles, which you can build them ahead of time or as part of your build process. Here's what the init Asset Bundle Manager script looks like. On awake, it starts the init coroutine. That coroutine tells bundle data helper to init the manager and passes through this as the coroutine owner. After that's done, it goes through the list of bundles to preload and kicks off loading them. I left the list empty for this sample project. I expect it could be used for bundles you'd want to load before the main menu, or to do a bigger load at the start of the game for things you know you'll have to load very early on to avoid multiple loading scenes, or on platforms that have lots of memory. So you may not want to do this on mobile, for example. After we've kicked off those loads, we tell the bundle manager to load the next scene. It needs the bundle name, the scene name, and a boolean which indicates whether this is an additive scene load or not. For convenience, we assume the scene bundle name is always scene underscore plus the lowercase name of the scene. Here's the bundle data helper. There's not much in here, really. Just initializes the manager and returns it when it's done. And the example loading code, you can have a look in the sample project. There wasn't really anything too exciting in there. Okay. Let's look at the editor configuration side of things. I've got level 1 selected in the project window. Oh, good, you can see it. I was worried you might not be able to see it based on the resolution. So in the bottom right, it says Asset Bundle, and there's a drop-down that says None. You want to click on that, and a little context menu appears. To create a new bundle, hit New. Easy, right? The Remove Unused Names is for killing off empty bundles. So that happens when you delete assets or when you rename asset bundles, depending how you rename them. As I've noted before, we're going to follow the naming convention of scene plus the scene name. Yeah, there it is zoomed in for those in the back. So that's it. Now level 1 is in scene level 1 bundle. In the toolbar, asset bundles, you'll find a bunch of utilities. The things that we care about at the moment is that the simulation mode option is ticked on, which simulates loading assets from bundles in the editor. And it is ticked on by default, by the way, so you don't have to tick it on yourself. And we also care about build asset bundles, which will, as you've guessed it, build your bundles. It's an incremental build. So if you've run it before, change some assets and run it again, it will only rebuild the bundles that were affected by your changes. If you've done a good job of organizing your bundles, you should consistently get short build times. The bundles will be built directly into the streaming assets folder, into a subfolder named as whatever your target platform is, Windows, Switch, etc. If you need your streaming assets folder checked into your version control system, you can simply add ignore rules for each platform folder, for each target platform folder. One such example where you may want a streaming assets folder is on Nintendo Switch if you want to play an MP4 video and you want to use their built-in Unity Switch video player, then you need to have the file in the streaming assets folder. I generally wouldn't put things in the streaming assets folder unless you had a good reason to. For scenes, they need to be in their own bundle. Level 1 has to be the only thing inside scene level 1, so level 2 would go in scene level 2. You can't have any other assets in that scene file either. For other assets, they can share bundles. For example, you could make an assets vegetation bundle that contains all your vegetation. But before we go any further, let's take a look at Asset Bundle Browser because it helps sort out this workflow a little bit. Just as a note, I've chucked in the Bundle Manager and Browser in Assets plugins. And to open the Asset Bundle Browser, you hit Window Asset Bundle Browser. Takes a little bit to open. Wait until the window opens up. Select the bundle you want to have a look at, and it will tell you the estimated disk size, which is pretty unreliable, but still something's better than nothing. So what's really important is that it shows you these yellow warning triangles that you can see everywhere. And that means that that asset is being automatically included in multiple bundles. So it means it'll end up being duplicated on disk and in memory, which is not ideal. There's a bunch of textures, mesh, and prefabs that are duplicates. So we want to go through these, logically split them into their own bundles. And by the way, this can be done using tools and scripts instead of having to do this by hand. But for this demonstration, I've just done it by hand. So 20, 30 minutes between the previous screenshot and this one. And I've split it up a bit now, and you can see it's now 136 megabytes versus 3.5 gigabytes, which is just rough sort of figures. And now the scene level 1 bundle is dependent on a bunch of those individual asset bundles, enemy, player, environment props, etc. And yes, I did notice that that Rock's foreground object is complaining, but it's a GI params file. which is an editor-only object, so I've just elected to ignore it. Something you'll notice when you split bundles is you can end up with a bit of a dependency mess. Keeping your project files organized will help with this, and otherwise it's actually a really good way to go through all your assets and see what's pointing to what, and you go, what's that character pointing to? Why is that pointing to that? And then fixing it. So, obviously splitting up data into modules when you're not familiar with the project can be challenging, but it does give you a good insight into how all the stuff is structured. As I mentioned before, you can definitely use tools and scripts to make this easier. Feel free to have a play with the bundle browser yourself, the asset dependencies, and so on in the sample project. One issue you will run into with asset bundles is with shader variants, the pragma multi-compile thing. If a shader variant stripping is switched on, which really it should be switched on instead of building like tens of thousands of variations, but there is an easy fix. When you see a stuffed material, you could duplicate it, pull out all the textures so it's really small, and include it in your shared shaders bundle. That seems to fix it. Asset bundles, done. Whew. Let's move on to data validation. It's a little more fun than asset bundles. So, the purpose of data validation is to support content creation, check for problems with configuration files, data, and scenes before runtime, and overall increase the quality of your game through finding bugs and reducing your iteration time. It's important to establish rules and formats for how you use your systems. For example, if setting up a new piece of content is technically possible to do it in a different way, but it goes against how all the other stuff you've done is set up, then don't do it, because it'll make checking that content for if things are wrong more difficult, and it'll take you more time. The time saved from doing things in a consistent way should be a net gain, and you can spend that time instead working on your features or adding more things to your game. The usage for this sort of validation solution is unique for each game, but it should follow the same principle. Providing confidence in the integrity of data you've created. It works best if everyone's on board in the team, but it still has its uses if not. You can even plan ahead and go one step further, and if you know you have tools to check the integrity of your data, you can plan to put a whole bunch of data in your game and make that one of the selling points. So, we'll split the script's usage into scene validation and project data validation. For scenes, we'll go through every gameplay scene, or level if you prefer, run the validate method on every I validate in the scene, and log out errors, warnings, and messages. For project data, we'll do the same, but we'll check prefabs data and assets on disk. So it's all fairly straightforward. I validate's an interface, has one method, validate. And to start with, I've just implemented the I validate on the send game command script from the 3D game kit. It's used to like open doors and do whatever. It's kind of a generic script that they use. I've also added an awake method. Now, in the awake, I call do validate. In region I validate, we have the validate method implementation, and it calls do validate. Do validate is a conditional method that checks the data. Here, we're just checking that the interactive object field that send game command sends its messages to has been set up. I'll show you the debug util assert later, but it's not too complicated. It takes a Boolean, optionally takes a game object and a message. The conditional and the do validate method will strip out any calls to it if the Unity editor keyword is not specified, or simply if it's built to run outside of the Unity editor. I'll show you what it looks like compiled with ILSpy in a little bit. Now that send game command has some validation, we use the toolbar and click on Tools, Validation Current Scene to run the validation on the current scene. I'll show you that script later too. The validation spits out two errors. If we click on the first interactive object must not be null error, it pings the relevant object in the hierarchy. We can select the hierarchy object, and with the mouse in the scene view, hit F to focus on the object. In this case, I already was looking at the little crystal switch thing. We can see in the inspector that there's two send on trigger enter scripts, and they inherit from send game command. So yeah, and it's something I broke on purpose for the demonstration. It wasn't broken before I touched it. So I fixed the errors by setting up targets for the send on trigger enter scripts. You can see the lines now rendering in the scene view. That's something that 3D GameKit does for the send game command things. You can see the little things. So one of the things tells the crystal to change color when you've pressed it, and another one points to a point in empty space. It's basically just a script that counts to 3. When it reaches 3, it opens that door underneath the crystals. So, hopefully you can see that a script finding the busted objects in a scene is way quicker than searching for it by hand. It's also way better to know that something is wrong now rather than waiting for it to break during runtime. You don't want to wait to find the problems until you're playtesting the game if it breaks in a way that blocks you, or if you miss it altogether if it's just something janky. Like, for example, if the crystal didn't change color, then you might miss it and you might make it into the shipped version of the game, which is terrible because people might be confused as to what's going on with the door if the thing's not changing color. So, back to the code snippets for a little bit. I'll show you what it looks like in IOSpy. So you can see the calls are stripped out. Now, debug util is also a conditional, so it was stripped out, but otherwise any code you had in there would still show up in there. And yeah, IOSpy is pretty cool and very useful for Unity stuff, so you should probably have a look at how to use it. The code you write will be in assembly C#, will mostly be in assembly C#.dll in that folder. And anything you have in the plugins folder, that'll go into assembly C# first pass. All right, now we don't want to run validation scene by scene. We want to do it by all scenes. You can go get a coffee or work on something else while the validation's running for the scene validation. So here's the validation toolbar code. Just tools validation current scene, run validate scene, validate scene. Goes through the root game objects and gets all the children, including the inactive ones, and it runs validate on them. For validating all the scenes, I've elected to get all scene files in a specific folder and pass in false to get scene paths because I didn't want any scenes from subfolders. I've also specified a search string, star.unity. You can check out the get scene paths method in the sample project. There's nothing really too fancy in there. Then we go through all the scene paths, pop up a cancelable progress bar for user feedback niceness, and open the next scene list, run validate, and loop. The cancel in the progress bar is unresponsive, but it will stop before it starts the next scene load, so that's nice. It's not the validation that's slow. The validation's fairly quick. It's the loading the scene that takes time. We then remove the progress bar when we're done, of course. There's the toolbar location. There's the progress bar. Level 1's done. Level 2's done. Both levels validated, no problems found. We only checked for one thing, so it's not surprising. Just as a note, also, I've not reloaded the scene that the user started in. I chose not to do it, but thinking about it, maybe it should be an editor option where you can kind of say, yeah, do reload the scene I was in, or don't, because I don't want to wait through another scene load. So there's also a small bit of code there before switching scenes. If you've got changes in the scene, then this thing will come up. If you hit cancel, the validation will cancel. Save, don't save will do what you've chosen and then run the validation. Just more user feedback niceness. You don't want it to lose your scene changes by running a editor utility. Okay, now that we've set up a bit of a framework to validate things, it's really, really easy to validate a bunch of other things. So let's do it now. Let's check if any transforms have multiple mesh colliders. That's never happened before. And I've just run this function in the root game object in the loop you saw before. It's a recursive function and goes through every transform. If it has 0 or 1 mesh collider, it's all good. If it has more than that, it's not, spits out an error. I also check the LOD groups because sometimes the LOD group renderers get deleted or moved, sometimes on purpose, sometimes by accident. There could be another reason why something's gone wrong. We just want to highlight that something's gone wrong so that the person making the level can go in and fix it. Okay, we see in level 1, Gateway Huge Teleporter has not 2, but 3 mesh colliders. I did not add those there, I'm pretty sure. And they're all identical. So the third one is at the bottom of the inspector off the page. I've left it broken in the sample project, so when you run the validation, you'll see the same thing come up. In level 2, we found a bunch of null renderers in LOD group LODs. Note that if you go to inspect a LOD, it will purge the null from the list. So if you run validation again, it'll go, oh, problem fixed, but it doesn't mean you've actually fixed the problem. You have to actually figure out what to do. Now, in this case, I didn't make this level. I can't talk to the person that did, so I had to make some assumptions. I've elected to just use the highest detail LOD and get rid of the LOD group. So I just got rid of the LOD group. In retrospect, that's probably not the best solution. You probably just want to set up the LOD groups again because you don't want performance slammed because someone's accidentally deleted something. The next one appears to be missing the highest detail LOD 0, so I've just set it up again. And this one just looks like it was meant to be deleted. Someone's grabbed the guts out of it, deleted it, not removed the LOD group. You get the idea. So, I've also added some other validation for scenes that you can find in the sample project. It detects whether there's a transition zone, which is something that is used to leave or finish the game, leave the level or finish the game. And kind of as a headline, if you have this validation idea in the back of your mind, you'll think of more things to check in each scene and how it can save you time and headaches in the future. Okay, so we've done a small amount of scene validation. Let's move on to the project data validation now. First, let's add some project data to be validated because there wasn't really that much. I've done the sort of classic RPG thing where just added a bunch of character classes to it. I also had to bump the gameplay numbers up. It was like everything deals 1 damage, enemies have 1 health, player has 5 health. So I just bumped it up to 50 health for the player, deal 5 damage for the player. The enemies have 15 health, deal 5 damage, and some enemies have more health. You can see I've changed, there was hearts there, I changed it to a hit point bar in the top left. It's kind of blurred out though. And I've added credits, your credits in the top right. You get, I give the player some credits from smashing crates. Used to get nothing from it, so figured that was a good place to put it in. The classes themselves. So they, the ranger starts with +20 max health, deals +2 damage. The smuggler gets more credits from breaking credits crates. You use credits to level up in this theoretical sample project game. You also deal more damage, etc., etc. The Cosmic Horror doesn't give you a description for a little bit of mystery, but you start with 20 health and you deal plus your max health divided by 10 damage. And every time you defeat an enemy, you gain +1 max health. I got a little bit carried away. And I got caught up in actually implementing these things. I implemented because it's fun, right? It's fun. I implemented the stat changes and a level up dialog, which pops up when you get 500 credits, but level up dialog doesn't do anything. It just takes your credits away. I was going to add skills that affect stats, more attacks, but I had to stop myself and just move on. I've put these things in assets, game, prefabs, characters. You can also see I've added a character called Character Broken example. Don't pay no attention to that. So let's go ahead and run the project data validation by hitting the usual stuff. Surprise, surprise. Character Broken example is broken. As usual, clicking on the message should ping the relevant object for usability. If it's more than 1 layer deep, you'll have to double click it to select it in the inspector instead of seeing it in the project window. So, it looks like the damage +1 object has a combat modifier damage. This is all little gameplay code I've added. So it has a combat modifier damage component, but it's missing the component which would tell it how much damage it should be modifying things by. Adding a simple modifier allows you to enter an amount, and that will fix the issue. Max health +15 has the same issue. I've left them both broken just so you can have a look. And it looks like the character class component itself is missing a name and a description, and has complained about that, so that's good. So, looking at the code now, we collect all prefabs with an iValidate component on the object root from that folder, assets, game, prefabs, characters, and we pass through true to include any subdirectories. So you could have groups of classes, and you might want to put them into folders. So we want to grab all those as well. We run validate on all the objects found. Keeping your project files clean and organized is generally a good idea, but it will help with all the other stuff you do, including validation. In character class, we check name and description, as you saw. If the game is not running, or rather if this was called from edit mode using the toolbar, we also want to validate the children under the root object. During play mode, we don't want to call it because they'll validate themselves. But there's not any hard and fast rules, just use whatever works for your validation process. In combat modifier, the class that combat modifier damage and combat modifier health inherit from, we check that there is exactly one modifier component, which is used in the calculation of determining the amount. So in modifier, we have some empty validate methods, and then its derived classes, like simple modifier, would check for whatever's relevant to them. So it will check that the mode's valid for simple modifier and that the amount is not 0. So that's about all I've implemented in terms of validation in the sample project. You can imagine if we had character skills, random encounters, enemy configurations, conversations, quests, any other data, we would probably want to validate that as well. User interface actually is another great candidate for validation because things get moved and renamed all the time. I was going to use a swear word, but I didn't. In general, when you encounter bugs in the game, which are caused by dodgy data or some person accidentally goofing something up, it's a really great guide for figuring out what to validate next. So you wouldn't want to validate everything ahead of time, but you definitely want to validate data that is likely to break, such as name and description fields for character skills achievements. If it's a big time sink to validate something, you can make a note of it for later and just do it in alpha or beta milestone if you're worried about it breaking. Since you're running through every scene and quite a lot of project data anyhow, you can also consider adding in reporting where it can provide value. Maybe art assets need to be checked for poly counts, texture sizes. Maybe you want to find unused assets to clean up your project a little. You can do the same thing for gameplay assets, like configuration files and data. You could check variety and balance if it's valuable to your designer or to you as a designer. But I don't recommend doing random reporting ahead of time. Just know that you can do it if the need arises. Data validation, done. Now, I just wanted to include some workflow helper scripts that I've found to be useful over the last couple of years. So debug util is fairly straightforward script. The thing that I find it handy for is getting the scene hierarchy location for when something breaks on someone else's machine. So, for example, you have a crash and it says, barrel top has broken, and you're like, okay. And you look in the level and it's like, oh, there's 300 barrels in here, awesome. So that's not particularly helpful. However, if it said environment.art.floor1.roomsmall.props.fishbarrel3.barreltop, then it helps you get a little bit closer. The assert method's fairly similar to the built-in Unity one, and you can comment in the Unity one if you like. There's no particular reason why I left it like that. The next script, prefab tools. So sometimes you want to change multiple prefabs and edit them in the scene, and you don't want to have to hit apply for each prefab change. That's what this script is for. Here's the rest of the code. You can find it online in the sample project. It just tells you. It also tells you how many prefabs were applied or reverted, just as a little user feedback thing. Now, this is a silly little script, but it saved me a minor inconvenience plenty of times. Sometimes you're clicking through component references, looking around at things, and before you know it, the thing you're looking at is no longer focused in the inspector window. Simply right-click on the component or scriptable object and hit ping. I guess you could also use it when you lock inspect windows. This find references script is super useful. The problem doesn't always come up, but when it does, you'll be glad to have it. Let's say you're looking through the scene hierarchy or some UI or prefab and utter the words, oh, I wonder if anything is referencing this. And then you wait a few moments and then the dread sets in and you go, I have no way to answer that question without extreme pain. That's when the script comes in handy. So just as an example, let's say you want to find what's referencing the Ellen player controller component in the scene. Right-click on the component, hit Find References to this. It will log out the references to the console and select the objects in the hierarchy. I've done a bit of Photoshop magic here where I've merged the before and after pictures together into one. So you can see I'm both yet to hit Find References and it's also found them and selected them for me. You could also extend this function to find references to the object by checking for every component instead of just the one that you've selected. So this start from master scene script, it's a convenience if you have a first scene that you always want to run from when playing in the editor. You choose a scene to start from, and anytime you hit the play button, it will load that scene up. Then when you come out of play mode, it will put you back where you were. So, yeah. And it's just more of the code. It starts off as inactive and use the toolbar to set the scene. So it starts inactive so it doesn't break when someone adds it to the project. And that's pretty much it. I hope this helps you fight the beast and escape the joys of bankruptcy. I have to do a shameless plug. So as I mentioned before, I port games to the Nintendo Switch with a group of other indie game developers. Feel free to get in touch with myself or Jason Stark from Disparity Games. Also, if you'd like to join the Ravencall mailing list and find out stuff about it when it's ready, feel free to do so at ravencallgame.com. Now, all the slides and the sample project with all the code I rushed through today is up for grabs. Head on over to either the link in the bottom right, or if you go to Ravencall Game, there's a little GCAP button. Any questions, but also feel free to ask any questions about gameplay stuff or Nintendo Switch, porting stuff, or whatever you like.
As you said before, that the iValidate stuff, does that all go like during gameplay as well, or do you strip it all out?
So the question was, does it go during gameplay, and well, basically like when does it run, when does it not run? The kind of thing that I've used the iValidate sort of solution for is in editor only. Or if debug is specified, you could specify another conditional. So you go if editor or if debug or whatever other keyword you want to use for testing your build locally. I didn't particularly want to run the validate on players' machines just for performance and bugs. Didn't want to add another thing that has to be checked if for some reason it goes wrong. However, the debug util assert method, I would leave that in for gameplay. So, you say, if you have some AI behavior and you say, okay, I expect to have an enemy target here, and I'm going to do some logic based on distance and whether I can attack them and whatever, then you say, assert, it's not null. And then if it breaks, you'll at least know exactly what broke. And you go, the taunt behavior on this AI broke when it tried to find an enemy. Then you can look at the behavior tree and go, it's because it didn't check that it has an enemy before it entered that behavior. Is that cool? Does anyone have any questions about? Oh, there we go.
How does using asset bundles change build size?
So it can increase the build size if you've got duplication.
Yep.
If you don't have duplication, it should be similar-ish.
So you can't really reduce it using asset bundles? They're kind of like
I'm not 100% familiar. I've used asset bundles for a few projects. The main reason why I wanted to just quickly, sorry, an aside, I will try to answer your question. The main reason I wanted to mention asset bundles was because not a lot of people seem to use it, and I've only been using it for a little bit, and it seems pretty easy, and it passed lot check, so it must be fine. So So to answer your question about size, now I know by default, or at least in this version that I've used, it does compress the bundles using its compression algorithm, but I think it does that already for the shared resources as well if you just build a project with all your levels in it. So yeah, I'm not sure that you would save any space necessarily, but it may load faster. It's less relevant on PC than it is on Nintendo Switch or Xbox or whatever. Any questions about Nintendo Switch stuff or gameplay stuff? Validation? Oh.
So with asset bundles, like you said that you had a script that just automates, like separating them all out.
Right.
So what's the best way to sort of separate them? Or do you do it like you don't want to do per file? You don't
No.
want to do it like how do you know where to stop grouping?
That's a really good question. So, and I like that question. And the reason is you can't answer the question without being familiar with the way that you're structuring and designing your game and your assets. So if you're an indie game developer and you're a really small team and you're creating the assets and you're doing the programming and whatever, then it's a lot easier. You go, well, of course, we put the characters with the characters, we put the skills with the skills, and everything kind of makes sense. But if you're an artist and you're like, okay, I'm going to drag this thing into the level, I'm going to drag that thing into the level, I'm going to point at that texture over there, it becomes really difficult. And it is something that we ran into on Hand of Fate 2, for example. But what was great about asset bundles was we were able to find all those sort of that dependency mess and kind of deal with it and go, why is this level using like a small mesh from a huge 3ds Max export file? It's pulling in like 17 megabytes worth of mesh, and it only needs like 5 kilobytes worth of mesh. So the best advice is everyone on the team kind of improving their workflow will sort of improve that. Now, as to how big it should be, you don't want to make one asset per bundle. I know it did get close to that for some things, but personally, I would prefer to group it in sort of logical chunks. For example, there might be a group of enemies that get grouped together. For an enemy, for an NPC, you might have the mesh and the texture and the animations and the sounds, or maybe not the sounds, but maybe the art side of things, that goes into one bundle maybe, because you might never see that texture without that mesh. You might never see that mesh without that texture, so it makes sense to kind of wrap it into one. Otherwise, what it will look like if you don't do it, if it's all the separate bundles, you'll see, troll texture bundle is dependent on troll mesh bundle. Troll mesh bundle is dependent on troll texture bundle, and really discussing things like that. So it's a hard question to answer, but you want to find a place where you don't have a dependency mess, and where you're still like not loading in 25 enemies to a level where you only use 10 enemies, somewhere in between there. There was another question over here before. I saw someone raise their hand.
I was just going to wonder if you had looked at, say, a unit testing framework or something like that, rather than using your own validate function, maybe pros between.
Yeah, absolutely. That's a great question. So my experience with unit testing worked with a developer that came from the web space, and they unit test pretty much everything. Which is great, checking the integrity of the code, making sure the functions are doing what they're supposed to be doing. I believe there's also built-in things you can do with Unity. It's really hard to communicate this concept of design and art crossed with programming, where you could definitely take it to the level of unit testing and go, okay, I always expect the data to do blah. I always expect this function to do blah. And And maybe that makes sense. You may decide that that makes sense for your implementation, and you should definitely do it if that's the case. The reason why I've left it a little bit looser is just to give a little bit more, I guess, freedom, flexibility, and speed to implementing other things. So you could go in and add a whole bunch of gameplay, maybe. But if it breaks off, and it's definitely worth doing, but if it doesn't break off, and maybe it's not worth doing, it's kind of a production project management decision in a programmer's brain, I guess. Is that?
That's right.
Is there any other questions anyone has? I think we've got 4 minutes left. Yep. No, all good? All right, well, thank you very much for coming to the talk. Feel free to grab the sample project.